Hello, in this video, we're going to talk about matrices. And a matrix is just a way to organize numbers, and it's a way to organize them with rows and columns. So a matrix, which is a rectangular array of numbers, in a blank in a matrix is a set of numbers that are aligned horizontally. So those are the rows, and then a column in the matrix is a set of numbers that are aligned vertically. When we talk about these matrices, we're going to talk about rows by columns. So everything is rows by columns. Each number is called an element of the matrix. Matrices are enclosed in these square brackets or these big parentheses and are usually named with capital letters. For example, here is matrix A, which is just 1, 2, 3, 4. B is there in C. It's often defined by its size. And when we talk about, and we'll talk about dimensions, which are rows by column. So this is a 2 by 2. This is a 3 by 3 because there are 3 rows and 3 columns. And then this is a 3 by 2 because there are 3 rows and 2 columns. It's very easy to get the rows and columns confused on a matrix. So kind of just take a minute to think about it. Just make sure you're not getting those flipped around. And just be sure you always put the rows first and then the columns when talking about dimensions. So there's a couple examples that up here. So matrix operations, we'll talk about addition and subtraction, and then scalar multiplication, and then actual matrix multiplication later. So with addition and subtraction, it follows your intuition. So what you would guess you would do. So like on example A, when you add these matrices, you're going to add each of these elements together that correspond. So like the first row, first column is the first row, first column, or like the top left is going to add or combine with the top left. Top middle with the top middle, top right with the top right. And it will create, when you follow that pattern, it will create a matrix that is the same dimension. So if I start with, this is a 3 by 2 plus a 3 by 2, or I just did the rows column stand. So it's a 2 by 3 plus a 2 by 3. Then we add just the corresponding elements together. So this would be -1, -6, and 0. And then -1, 0 plus -18 is -18, and then 9 plus 4 is 13. And so this is the result of adding those matrices together. Now, when you have a problem is something like this. So here, if I try to add like this one to this one, it doesn't work because, or that's fine, I guess, first row, first column, first row, first column. But then I don't have a second column over here. There's nothing to add to this. So this is just undefined, or it does not exist. So when can matrices be added or subtracted? Dimensions must be the same. So if you try to add or subtract matrices that aren't the same dimensions, you'll just run into some issues. You won't have numbers to add, and you just can't do it. Here, when you subtract, think about distributing. You're going to subtract every element, so really watch your sign. So 1 minus -2 is 3. -5 minus 1 is -6. 4 minus 4 is 0. And -3 minus -1 would be -2, would be like adding. On D, this is called scalar multiplication. And you can, this is also intuitive. If there's a number in front of a matrix, your best guess would probably be, well, I'm just going to multiply everything by that number. And that's true. You can think of it as distributing that number. And so this matrix would become 6, -3, and 21 with 1 row and 3 columns. Okay, another way we like to set up problems is by using variables to represent matrices and write expressions and evaluate these. So now would be a good time to pause this and see if you can find A, B, and C. We are going to write these out. And I remember doing these in learning about matrices, especially in college in linear algebra, and finding it so hard to keep up with the guy as he was writing, my professor, as he was writing the matrix out. It was like, because it wasn't natural to me. I always do start at the left and right and then move down. But just take your time. I know it's a little frustrating. It's a lot of numbers. Okay, so then x plus z is just matrix x plus z, and so just add these numbers. I do recommend you write these down, although you could just like show your work, in other words, although you could just do this up here. But it's really easy to mess this up. So just add the corresponding numbers, which I should probably pay attention to so I don't mess it up. So then 5 plus 7 is 12. 10 plus 5.5 is 15.5. Decimal, still just a number. It doesn't matter. 4 times z, school starting. 4 times z is just multiplying each of these numbers by 4. So 4z is just scalar multiplication with the 4 out front. So that is 4 times 9 is 36, and then 24, 20, negative 32, 28, and that would be 22. And then 3, and then y plus x. You can do this like as 3y plus 3x, or multiply the 3 last, which is what I'm going to do. So you can distribute this. That's an allowable operation. Let's see, I'll write it like that. So I'm going to find x plus y. And once again, if you need to pause the video so you can try this, that would be wise. So x plus y is 4 times 2.5, or plus, not times. 4 plus 2.5 is 6.5. And then 3, 3, 6, 4, 10 plus 1 is 11. So once again, I'm getting those just from combining like terms, or not combining, or just combining them or adding them. And then multiply everything by 3. Was there a negative? Okay, looks good. So that's 19.5. 9. 3 times this 3 is 9. 3 times 6 is 18. 12, and then 33. Okay, in this next example, for solving for x, y, and z, it's given that the following matrices are equal. So if matrices are equal or equivalent, that means the same dimensions. And it also means corresponding elements are equal. So that means this element here, like you can see some of these without the variable. So 0 is the same as 0 because it's the same spot. 6 is the same as 6. So 4 must be equal to x. If you look at this top first row, first column, first row, first column. Okay, that's done. There's nothing to do there. So we know x. Y is right here, so that must be equal to negative 2. So negative 2 is equal to, y plus 4. So they just solve for y, get y by itself by subtracting, and negative 6 is equal to y. And then z must be equal or z over 3 is equal to 3. So 3 is equal to z over 3, and you can multiply by 3 on both sides to get 9 is equal to z. So that is x, y, and z. Here we're talking just a little bit about matrix multiplication. And I do apologize for the bell. That's a bummer I hit that. So when you talk about matrix multiplication, it's more complicated than the other operations. And so we're going to do an example here, but I really probably recommend you need to either see more examples and more practice to do this and learn to multiply matrices, or use your calculator, which is kind of what I'll recommend from this video and see in this example. So we'll see how it works and then learn how to do it in whatever type of graphing calculator you have. And I'll link to that because I don't have a good way to show you right here. So when can we multiply matrices? The matrices, to multiply the matrices, the columns in the first have to match the rows in the second. Okay, so that is the last spell. You were late for class if you're not there already. So columns in the first have to match the rows in the second. So order matters with matrix multiplication. Okay, so the other way to interpret this is, and we'll talk about what I mean by this, is the middle numbers are the same. Or we'll say middle numbers equal is how I would remember that. And what I mean by that is, so if I want to find this product, this multiplication, so this is 2 rows by 2 columns. Man, what am I doing? 3 rows. I was like, this doesn't seem right. 3 rows by 2 columns for this first matrix. And I'm multiplying that by a column with 2 rows and by a matrix with 2 rows and 1 column. So because these are equal, then it's possible. So because those are equal, it's possible. And my dimensions, my product, is the outside numbers. So these 2 numbers, the 3 and the 1, those give me my product. So the answer, or we'll say product, is 3 by 1. So those numbers right there give you your dimensions of the product. Okay, and like I said, this is a confusing thing to do, but what you're going to do is multiply the rows by the columns and then add. Okay, so what does that mean? I'm going to set this up, and remember, order matters. I'm going to rewrite these a little bit so we can see this visually. So you put the first matrix down here, and then put the second matrix up here. And then the result is going to go right here. And this is a nice way to line everything up. So, and like I said, this is tough to do. And so you'll want to see more examples if you really want to learn this by hand, but I can tell you how it comes about. So we do 5 times 1. So we this first row is going to go in the first row, the first column. And you multiply the corresponding elements. So 5 times 1 is 5. And then you add 0 times -1, which is 0. And then if I want here, I'm going to go to this row and this column. So 5 times -2 is -10. And then I'm going to add 4 times -1, which is -4. 5 times 5 is 25. And then 2 times -1 is -2. And then simplify, so add those together, and you get 5. Oh, sorry, that's not very neat. What was that? -10 and -4 is -14. And then 25 minus 2 is 23. And so there is your product. Notice it's 3 rows by 1 column, which is what we expected. So order matters with multiplication, matrix multiplication, and it's not always possible. If you picked up on matrix multiplication after that first example, I'm very impressed. Like I said, you'll need to do some more research. We're not going to dive into it in this video if you want to do it by hand. And I will link to how to do some matrix multiplication in the calculator, as well as solving the system of equations with matrices. So the way you do this, or one way to do it, is to use what's called reduced row echelon form. And I'll link to a video with the graphing calculator because I don't have one here. But your first thing is just write what's called an augmented matrix. So you write this matrix, and we'll call that matrix A. And then, like I said, I'll link to this video, so we're not going to go into it, but you're going to use calculator, and you're going to use RREF, this operation. Okay, and then one more other thing about matrices, just real quick, is the determinant. So the determinant is actually, it's not a matrix value, it's a scalar value, and there's a lot of uses for it, but we'll just define it here. So in matrix A, or we'll just say in this matrix A, B, C, D, the determinant, let's call it A. Then the determinant of A is equal to AD minus BC. So this is something you can also do in your calculator. There's an operation for it. Also changes with the size of the matrix. So if you do a 3 by 3 matrix, the definition for the determinant is much more complicated. Here, it's something that can be calculated by hand quickly, and actually it's quicker to do it by hand than in your calculator. Notice though, like the pattern. So this is, you just multiply down, and then subtract. The other way you will see this represented. So if I say find the determinant of the matrix below, I could say DET like we did up here. Or if you just have straight bars, look like absolute value bars, that is the symbol for determinant. So that means to do 2 times 6 and then minus 3 times -1. And really watch your negative signs. If you're doing this, I recommend writing it out. Maybe not this much, but you can go ahead and like multiply if you want. But definitely write one step out, because a lot of people make a mistake with that negative sign in the subtraction. So we have 12 plus 3 is 15. Okay, so that's a pretty brief overview of matrices. But if you have any questions in some of their operations and such, if you have any questions, please reach out.